Now that we have the solid mass here, that's the beginning of our pulley, the next thing that we need to do is cut in the V groove that will take care of where the belt would lay. So we started this entire thing on the right plane, so we're going to go back to the right plane to do this. So I am going to sketch on the right plane, and since it's already built, it is not automatically doing the look down on it, so we're going to do that ourselves. I'm going to come here and just stare right down orthogonally to this plane. Okay, so now we're in the sketch. You can see it's up here, sketch. Remember that little negative means that it's not fully constrained. Well, the whole thing's not done yet, so it's not fully constrained. Our other sketch here, you'll notice there is no negative sign because it's fully constrained, which is what we want. So now what I'm going to do is I'm going to draw in my line. So I'm going to zoom in here on the front. I'm going to, you see how it's showing me that there's a line there. I'm highlighting it. After a couple seconds it comes up. That's the edge of the part, the silhouette. So we can draw on this, which is great because now this line will always be associated with that silhouette. So if the line gets bigger, or if the part gets thicker, it will all change in relation to that. And that's why it drops in as black, because it is constrained against that. The only unconstrained part are going to be these two endpoints here, and I can drag those, and they're not there. So the other thing I want to do, though, is I do want to put in another center line, because I am going to be doing some revolving again. So once again, I'm going to start here from the middle. I'm going to bring it out just like the other one. It automatically grounds itself horizontally. I'm going to do the same thing vertically. Oops, it didn't come in, so we'll grab it there, bring it up so it's vertical. And once again, the nice thing about center lines is they're much like construction lines. They aren't really there, but they're there. It allows us to do what we need to do. So let's go back to our normal, regular, everyday lines and draw the rest of the keyway. So it's going to be flat here on the bottom, and we're going to have two angled sides to it. Okay, so there we go. Let's get this to be everything in the black. So what I want to do is let's go and use those symmetric constraints again. I'm going to select my two sides. I want to make it symmetric. And so now that those are symmetric by nature, they're going to have the same angle, so they will have the same height, and so everything's good there. It's a good way to lock things in without having to use a lot of constraints. So I'm going to make this bottom one here 1/2 inch wide. The cut itself is going to be 1/2 inch deep. And so the last thing that we've got, those lines are blue, so what does that mean? Well, we can kind of grab it and drag it and see what's going on. Well, it seems to be locked into place. Well, oh, there it is. It's the angle. So let's go and put in an angular dimension right off between the two of them. So right there, and we'll say that's 40 degrees. Okay, so completely black, so it's all grounded. Let's go and make our keyway. So instead of I'm not adding material, so I'm not doing a revolved base. I'm going to cut. I'm going to be taking material away, which is a cut. So we're going to do revolved cut. And so axis of revolution, just like before, we'll pick that there. And it goes, well, yeah, this is the cross section you're working with. I'll cut it out for you. And that's what we wanted to do. The preview looks good. I'm going to hit OK, and there we go. So now I have a keyway cut, or a beltway cut into it. Why didn't I just draw this all in the other one and do it as one complete revolve? You could most certainly do that. A lot of times, though, it is nice to just deal with things in smaller parts because it makes it easier to adjust things if you need be. Especially as parts get more complex, there could be issues with modeling. And this really comes into play, one, if the parts are really big, because you got to remember the computer modeling is just nothing but math, and divide by zeros are bad. The other thing is if you have somebody that does a lot of analysis work with these models, stuff that I used to do when I was in industry, you're running all these strength of materials equations. Sometimes you need to turn off features so the computer can just calculate the numbers. Especially fillets, which we'll be doing here in a second, are notorious for crashing the analysis part of the model. So let's move into that fillet now. So a fillet is a rounded edge that happens basically when a tool goes in to cut things out. We typically are not using a flat end mill or whatnot. We're using a ball end mill because it's cheaper. And we can just carve a lot of material out. So how are we going to put the fillets in? Well, the fillet is a surfacing command, and it's right here, fillet. We've got a fillet and a chamfer. We're actually going to use both of those. So let's start with the fillet. So the fillet allows us to do, you can see here, these are all just blending operations. We're blending two surfaces together. We're going to be using the constant fillet size. It's the easiest way of doing things, and so I want to get right here on the inside edge there. We'll rotate it to the other side, and I'm also going to get the inside edge there. Since I'm in the fillet command, there's no need to hold down the control key because we're just in the items to fillet selection box. We're also going to want to get the base of our boss sticking up. So we've got those four edges. We want to make it a 0.25 inch radius. And you can see, usually we have that preview off. So if you put a partial preview, it'll show you at least one. A full preview will show them all to you. Now, usually you have, a lot of times the preview's off just because of processing power. I thought I put that in right, so that's a 0.25 inches. And we can do the the full preview to go, yeah, okay, look, it works, there's no problems, and we'll hit enter. Filleting command is one of those surfacing commands. It gets done at the end. It's like one of the last things you typically do. So that's a fillet, and that's a rounded edge. And so we can also do a chamfer, and a chamfer is a break-off edge. So you're just breaking the corner. A lot of times that can be for seats and whatnot, to be able to slide something in, two pieces of metal against each other. And that's typically a pretty, it's a pretty quick thing to do on the tool. And I just took a look at the part drawing. There actually is no chamfer in there, but let's just throw one in real quick and then I'll get rid of it just so you can see what it is. So if we go under fillet, we go to chamfer, and items to chamfer, different chamfer types. Typically what you do is you give it an angle and a distance. So let's just, we'll pick that edge right there, and we'll give it a distance of 0.4 inches is way too much. Let's say 0.010 of an inch at 45 degrees, and there we go. And so you can see it just comes in there and it just breaks that edge. But I don't want that there. So I'm just going to go click on my chamfer and hit delete and say goodbye. And then it goes away. So the last thing that we did want to do, though, is we wanted to put in, I've got that keyway. And this is going to be a straight linear cut. So we're going to do an extrude cut. I'm going to hit that first, and then I'm going to select the plane I want to cut on that plane. And then I'll go here to my orientation. I'll look straight on it, because just like everything else, it needs to be fully constrained. So I want to take a good look at it. I need a rectangle. There's my rectangle. So I've set it up, and now let's work on getting this one constrained. First of all, I did put it on, I thought I tagged it to the center, but I didn't. That's why I was able to drag it. So what we're going to do is I'm going to click on the center. I'm going to hold control. I'm going to click the bottom line. I'm going to say, not just make them coincident. I'm going to force it to go to the midpoint. And so that kind of does a couple things for me. Since the midpoint's always in the center, that means no matter how I flex this thing, it's always going to be centered. So that makes things easier for us. Now I want to make it 1/4 inch wide. So I'm just going to pick that and say, let's make that 1/4 inch. And the last thing to do is I need to know how far from the center that is. So I look back at my drawing, and that's 600 thousandths of an inch. We'll just drop that right in there. And okay, so you can see where it's going to cut the material out. And we will hit OK. We are already in the feature tool, so I'm just going to exit the sketch here. And it's going to automatically go, okay, let's cut. Which is great. So what we're going to do is, well, we're just going to carve that keyway, and we're going to blow it all the way through that material. So instead of blind, we're just going to go to through all, and that's just going to take it and cut all the way to the bottom. So all the material will be gone, and there we go. I hit enter, and we rotate onto that, and there we go. And that just blasted that cut all the way through the material. And so there we go. We have our pulley, we have our keyway. We'll make a drawing of this in a couple of chapters. But a couple of things that we can do is we can go into our properties and start taking a look at what's going on with our material. And so what we want to do is if we go to evaluate, and we have a lot of different properties that we can take a look at. And so if I go and click on mass properties, I can look at it and go, oh look, there is my center of mass. There's what the mass would be. We can see that we have a default material put down on this. And so we're not really getting good data. So let's change the material. So if I go here into material and click on that, go right click, go edit material. Well, let's make this, let's grab something. Let's go with chrome stainless steel. That's always a fun one. I hit apply. And I can close this now. So I have chrome stainless steel. Doesn't really change the visibility too much, but now if we go over here to mass properties, we can see that weighs at 0.28 pounds per cubic inch. So our pulley has a mass of 8¼ pounds, has a volume of 29.33 cubic inches, gives us a surface area. You might be looking at that going, wow, that's kind of weird. The center of mass is 0, 0, 0. What's going on? Got to remember, we did a revolve part, so this entire thing is set up to the origin of the part is right in the middle, because these numbers are all how far that center of mass is from the origin. So we're right smack dab in the origin. 0, 0, 0 is where our center of mass is going to be. And so there we go. That's a pulley using a bunch of revolve commands and just looking at some of the stuff that materials can do for us. Now the question is going to become, couldn't we have done all of that in one revolve? Couldn't I had all the fillets and the keyways and everything all in one revolve? Yes, you could. But once again, as I said, especially with like fillets, we like removing those for analysis and breaking up complex parts into smaller individual parts. There is nothing wrong with that. But you could do it really big, but there's no reason to have it that complex. It's definitely better to keep the models build-wise as simple as possible. And with that, that is the end of this video. If you have any questions, please let me know. Otherwise, I will see you in the next video.